Kn, this is theta. Put some alpha. KH, you write it. Yeah. Elastic collision is stilling. So applying conservation of momentum. Deuterium, will it get excited? No other information is available. Just it's only pure. Pure, it is what? Some sort of collision concept, nothing to do that one. Applying the same, a neutron is scattered through if neutron loses 2/3 of its initial kinetic energy. Initial kinetic energy, say let it be K naught. So how much will be left over? K naught by 3. Then as it is elastic collision, so how much it should be? 2 K naught by 3. Okay, the theta has to be determined. Let me mute everyone. Yeah. Conservation of momentum. So 2m K naught should be equal to 2m K naught by 3 cos theta. Directly write it. No need to write so many symbols. This is 2 into 2m 2 K naught by 3 cos alpha. Theta and alpha known, solving that will get the required answer. Then along y-axis, answer will be 9. Check later on. Okay, will it be 9? Huh? Yeah, fine. Nothing to do, just I think basic collision. In the problem, if this gets excited, will it be elastic collision? Very nice thinking is what you should do. If this deuterium gets excited, let's assume that one. It's a deuterium atom, let it get excited. Will be elastic collision? No. For it to get excited, it should be inelastic. I don't think so. We can continue in this way only. Of course, we can write equation all, but he has to put a condition, cannot be elastic if this gets excited. So they may test you with these things. If a student says deuterium excited, then collisions must be inelastic.